we have 4 guests. This is what we are roundtable on a very challenging aspect, which is already, as we will see, daily business on mobility networks, on mobility ecosystems, which is artificial intelligence, but at the same time is still a concept whose potential really needs to be discovered and correctly driven, as we are learning, correctly driven towards sustainability, towards applications in mobility that can really enhance the quality of services, their sustainability, their inclusiveness, and so on. So for this reason, we have invited our 4 guest speakers to discuss their view on artificial intelligence. So we have Joseph Laborda, Marco Federzoni, which unfortunately could not join us in person, but kindly accepted this video call. Then we have Albert Schmidt and Hamid Mostofi. They will introduce themselves in the first round, but we decided together, so we are all responsible, that we will really start with a very, very quick look at your background and a very short and direct question: why are you here? So, what is your expectation on the course, but on getting a better understanding of the potential of artificial intelligence? So, there so they can recognize you, but I think it's very interesting to have this, let's say, very useful for our speakers to try to understand who they have in front and what kind of language they have to speak. So I will start here with Khalid.
Okay, hi everyone. Khalid Noor from NEOM in Saudi Arabia. Mobility systems and planning manager. Background in technology, mainly electric transport. Interested in the practical application of different digitalization aspects and how we can put them into work in real life.
Hello everyone, my name is Jaime Valdez. I am the mobility manager at the city of Lindau in southern part of Bavaria. I am here because I'm really interested in all the possibilities that digitalization is offering in the mobility ecosystem. So I'm looking forward to the content.
Hi, my name is Jana. I'm an innovation manager and a UX researcher, and I want to go into the mobility sector more. I'm very interested in all of your opinions about artificial intelligence when it comes to analyzing real-time CCTV data. My case is about autonomous shuttles coming to Hamburg very soon, where I live, and I want to know if you can detect dangerous behavior in these vehicles before they occur, so that vulnerable groups such as women or people from different backgrounds are feeling safe even though they're smooth drivers. So I'd like to hear more about that.
Hi, my name is Atul Vidan, and I work for ECRI, Local Government for Sustainability. I'm the head of the Global Sustainable Mobility Program. And I'm interested in this course because we started a project in North America related to digitalization of transport, and in particular, the organization will be responsible for digitalization of last-mile logistics. That said, across all our programs, we have been countering more on digitalization, and in particular for AI, since the work it's more in emerging economies, it will be interesting to see also how to find a bit more cost-effective solutions and also understand a bit better the applicability rates in real cases.
Hi, I'm Carla. I work for the Mobility Export Institute, the national agency. I work for the national government, especially with policies around transport and mobility. And I'm interested in understand systems, especially because of the legal frameworks and some interesting projects that they can involve along the public transport and so on, the impacts.
In Portugal.
In Portugal, yes.
Hi everyone, my name is Juan Moran. I work with Khalid at NEOM. I'm a regional and urban
planner, mobility planner. And I'm just interested in digitalization and how to apply this new trend or this new advance into the real life and real jobs.
Hi, I'm Fernando Fontes. I'm an electrical engineer that transitioned to mobility 7 years ago. Nowadays, I work for the city of Berlin, specifically in the Department of Mobility, Transport, Climate and Environment with shared mobility. And my expectation is to get an overview of the trends and digitalization and which are the opportunities in the perspective of a city.
Good morning, I'm Maduro Guartemendia. I'm coming from a small town in the Basque Country called Beasain. I have background in architecture and commercial management, but for the last 4 years I've been involved in politics and political representative of the Territory Commission of our city that involves urban planning, mobility, energy and all that. I'm really interested in the use of digital technologies, including AI, obviously, for the improvement of the mobility of small cities, which means that the investment has to be and the maintenance has to be cost effective. Thank you.
Hello everybody, my name is Juana Dino. I'm from Bucharest, Romania. I work in the University Polytechnic of Bucharest. So I'm a teacher and I want to get up to date with digitalization as it gets more and more present in our nowadays life. And I think that our students need to understand this change in the other paradigm.
Hello, my name is Barbara Steckermeyer. I work for Deutsche Bank, project Digitalizing in Deutschland, translated to Digital Rails of Germany. And I work for a project which is called ScanMed, from Scandinavia to Mediterranean Sea, in a section in Germany. And we want to keep this, not only this, but I work on this transit corridor with DCS and digital interlocking and so on, all the cutting edge technology in railways. And I'm here to also brighten my horizon and to see what generally mobility and digitalization, how it fits together and trends for other industries. So, yes, I'm very happy to be here.
Hi, my name is Maxim Heckert. I'm working as a consultant for a project manager here in Berlin. We mainly working together with local authorities when they want to implement some funding programs. And that's why I'm interested in general in new solutions of digitalization technologies in especially public transport or public roads.
Christoph Stürmer. I work just across at Charging. Charging is a global association for electric vehicle charging, and we're concerned with standardization, of course, of infrastructure interfaces, which makes infrastructure work.
I'm not saying why you know these things.
Great. So let's come to our guest. I would ask Albert to break the ice, to tell us a bit more, of course, about your role, your relationship with the AI topic, and what you think AI can bring in the mobility sector, is already bringing and can bring in the future in the sustainable mobility sector, where we're all interested.
Excellent. First, maybe it's a super interesting group you're representing with all the varieties. I think it will be a pleasant talk, maybe also speaking for the other colleagues here. Artificial intelligence integration is for sure for the next 5 or 7 years the big topic. But I think the understanding what means artificial intelligence and how much it can really bring has to be assessed. Because today there is a lot of hopes, and we can compare those hopes with the 2014, 15 YouTube videos on autonomous driving, where there was a panacea of autonomous driving, what will be possible, how will it look like. It was driven by thoughts, and there was always a big topic vision, make a vision, and then reality came into place. And this is a bit what I assume will happen with AI as well, because when you are on private territory, it is very easy. You can justify, I do what I can do. When it comes to public grounds, those that are policymakers here, public grounds are regulated, and they have to be regulated. They have to be fair for everybody and they have to be safe. So, as I can speak best for autonomous driving, if you would put all hopes for AI into the basket of autonomous driving today, you surely create the most unsafe public ground you can imagine. So this is why it makes a lot of sense to look into details and to understand how this AI has been constructed, can be decomposed, and by this decomposition, what is replicatable, what is approvable, and what can be presented to a third party to an assessment in a safety case by someone who is maybe not as educated as an AI coder. This is the next topic, asymmetry, because we speak here now on this, so to say, top level world. There is for sure the techno world, and this techno world has to be understood. Making this techno world understandable means documentable. That means if the third party has to assess the safety, they have to see a document which is understandable for another one. So if you create documents no one can read, no one can give you the stamp that you are allowed to drive, to move, or whatever public ground. So basically the transferability by curing this type of asymmetry will be a big topic. And lastly, it has to be analyzed. We're sitting here for sustainability reasons. It has to be analyzed what is the true impact of AI on sustainability. So autonomous driving has faced and still is facing a lot of challenges, and those challenges do not lay in the options which are there. Those challenges lay in the true use, in the finding of the right use cases. I heard here from Jana the shuttle topic. It's so much money that needs to be put on the ground, and then there is a topic depreciation. We can also discuss a topic, how can AI be depreciated? So just by having a specific knowledge or AI doesn't mean that there is no depreciation on it. And this depreciation looking at cities has to be managed, because at the end, on public ground, things have to be tendered. So when you make a tender, think about the depreciation. So you can imagine what it started with, the most costly AI world. If it is at the end affordable for municipality, is another thing. So this has to be taken into account as well. So I think it's to close my loop, so to speak, it is most relevant to address today what is realistically gained for sustainability and financially, and what can be achieved also in the next 3 to 5 years, and not becomes just a dream like autonomous driving 2014, and then you hit hard in 2035 reality with AI. But rather be realistic today, what can be pressed today already in a software license, approved by a third party, documented, understandable, and then brings value to the table instead of living in dreams. We say goodbye, and in 2 years we meet again, and it's basically the same, nothing has changed.
Yes, what can be done? That was a good, great question.
Yeah, very quickly introduction. You touched on a number of important topics for today. So before that, let me introduce myself a little bit. So I'm from Barcelona. I'm co-founder and CEO of this company, Flashbulb, and we are an innovation and strategic consultancy specialized in mobility. But our USP, I would say, is that not only we do consultancy, sort of a more theoretical analysis of trends in technologies, business models, in mobility and everything, but we also do applied innovation. So we are quite good at securing EC funds. From European research, we cooperate with all the stakeholders, with the industry, with research centers, with academia, and so on. In research projects, we eventually test where AI or different versions of AI put a real value and addressing real concerns and real problems. And we do this using our engineering sort of background that we have, which makes our USP quite complementary and quite unique, I would say. So having said that, there's a number of very important topics that you touched, and I would like to introduce a couple or three more. One is, let's not make the mistake of pretending to do everything using AI. So AI is one of the latest buzzwords in our industry and across many other industries as well, not only mobility. And in recent times, it seems like if you are not using some sort of AI, you're not innovating, right? So AI might be very effective technology, and of course, within AI there are so different approaches to AI, right? AI is kind of an umbrella topic, right? But let's not pretend to use AI in every single environment, right? I mean, self-driving cars are a very good example. So if utilizing AI has safety implications, and self-driving is eventually one of the most safety-critical applications where utilizing AI is really critical and really dangerous in some situations. So let's not pretend that AI will work for everything. Instead of that, why don't we think of applying AI in many use cases where it really adds a lot of value, because it can use an algorithm or code, right, to take decisions in a much more efficient, in a much more streamlined way as compared to humans, right? I have some examples where we are applying AI in not that much liability critical scenarios, right? So yeah, I would like to touch a few more topics, but yeah.
Good, thank you so much. So yeah, I'm Hamid Mostofi. I'm a researcher at Technical University of Berlin in mobility research cluster. It's my honor to work with Massimo as well since 2017 until now. And also I'm a professor of data science and artificial intelligence at SRH Berlin. So I have two affiliations. In this case, because that I'm coming also from the research and also education background, first I would like to speak about the level of knowledge about AI for organization, because all of you come from the organization, so you have the kind of the profession. So regarding my project that I had, and also what I see about the trend of the software, working with AI, with specific data, cannot be, that it can, in 5 years, it can be like the knowledge of working with Excel in Office, from Microsoft Office. So first, this is a little bit a radical prediction. So don't think that AI, wow, I have to be a computer engineer, or I have to have, for example, the degrees of the, for example, computer science or cognitive science, and such and such. So why I tell that right now, today is the 29th of May 2024, so 5 years such as 2029. Why I'm talking about that? Because two big revolutionary technology, cloud computing and also cloud systems. These are the two, the first one, and the second, actually, because of the big advantage of Python as a language, which is really near to our speaking language or talking. So these 2 points make every day, or I can say that even every hour, AI easier and practical for non-computer discipline employees. So now, right now, that thanks to the big organizations, or that whether you like or not, that such as Google, Facebook, or Alpha in this case, that right now we have for example, one example is the Google Colab. So Google Colab is the one platform that even with 2 hours, just 2 hours working with this case or even reading some document, you can start to work with AI, with your data. So Google Colab means you can have access to Python and AI, artificial intelligence. I'm talking about the AI, I'm talking specifically about machine learning. Yeah? So we have different types of machine learning that I will explain about that. But practically, when you want to work with machine learning, for example, convolutional neural network, for your case that we said that the CNN, to analyze, for example, the photos or images for autonomous vehicle or this case. So first of all, again, because of the new technology of cloud computing and Python, you should not write the code. Just you need to import this machine learning package in a one framework, give data to that. Of course, your competency and your skill is preparation of data. This is a big question that you need to learn. But about the technology, you import the AI, I mean that the CNN, you prepare your data in which platform? In Google Colab, and just in 2 or 3 hours. So do you think that this kind of the knowledge is a kind of the secret knowledge, is a kind of a specific profession in your organization? No, I say that this is a kind of the ICBS, it's a kind of the Microsoft Office with Excel. So it means you just need that which machine learning should you import, how you can prepare your data, and which platform you should do that. And this is exactly like Excel. So you have one table, import your data, select some option, import your place and route. Yeah? So now come back to the application of AI, what happens as also in continuous to the other cases. So the difference between for example, one student, new graduated students, and the big organizations, such as, for example, PVC, or this case that they are working on this AI right now, or, for example, I don't know, like, I mean, that is just even Deutsche Bank, that right now they have their own ChatGPT or with their name. The difference is preparation of data or finding a reliable data, yeah? So if you have a reliable data or prepare the data, then the rest of that is a piece of cake. It doesn't mean that you are a kind of Einstein to prepare the whole of this data. So what is my advice right now? I mean that now we are 5 years before getting the knowledge of AI as a kind of very ordinary knowledge, yeah? So you are 5 years ahead. So I really recommend you, I mean that in this case, learn about this collaboratory or the cloud computing Python. It is very easy that you can learn in YouTube, just in 5 or 6 hours you can see, and then learn different types of machine learning. Now come back to the topic, which kind of machine learning you need, I mean. So, if you are working in a business area, if you want to know that implement AI for your business data, for example, customer segmentation, prediction of the number of, for example, your customer in the future. How many people will use public transport or private car? How many people, for example, use your charging station based on your price? This kind of the social economic question you can use as a kind of the clustering and classification machine learning algorithm as in a classic machine learning, yeah, or ensemble machine learning such as random forests. So all of them is the algorithm of classification and clustering, and ensemble machine learning are very frequently used in social economic analysis. If you want to analyze the image, autonomous, for example, is a very technical cases, such as you said, autonomous driving, or image processing, or even, for example, language detection. So now you need the deep learning with the big data. And in this case of the deep learning with big data, so we have a convolutional neural network and recurrent neural network, and also the generative AI, the next level. So all of these packages doesn't mean that you have to write the code of them. You need just to find the reliable prepared package, read the instruction of that, and implement your data in this case. I finished my point. So how we can find this kind of the libraries? So we had thanks to the open source movement in the world, that this is also another social topic that, for example, how people and communities try to make a free AI world or such as that, this idea. So we have open source libraries in internet, such as TensorFlow, which Google also, for example, support them. Or, for example, we have by the Facebook, for example, Torch or such, this kind of it. So TensorFlow or scikit-learn, the term on the scikit-learn. So you can search in internet scikit-learn, then you have all of this package and instruction, how you can prepare your data, which package you can use on this case, and of course, even you don't need to install Python. As I said, that cloud computing systems such as Google Cloud, and then you can experience 5 years before this kind of the popularity of this stuff. So I will finish here, and then look forward for your questions.
Thanks. Thanks, Amit. I think it's time to ask Marco, which is patiently listening to us, about his activity and how you use artificial intelligence in your business as usual nowadays.
Yes, hello. Can you see me here good?
Yes, great.
Good. Thank you. So, well, you see behind me the WebKit solution that may be not a very well-known brand. I am part of the Bridgestone Mobility Solutions company. That means that, maybe it's a bit better known than Bridgestone, and it's well known probably for that round black thing that we call tires. But again, this is what digitalization brought to the market. Just to give you an idea, we basically want to stop. We actually already stopped selling tires, but we started selling kilometers. And that's the difference between so that what I read up to now, it's really also very interesting for me, because I'm the humble part of this group, because I use all the technology that you've been working on. So that's I think that's the value of this, is that as it's just been said, it's not, I do agree that artificial intelligence will become the new Excel. I perfectly agree with that. So it's about how we use it, and we shouldn't be scared about it. In our platform, I also heard a lot about platforms, and WebKit Solution is actually a mobility platform. What is a platform? It's a digital place where we actually act together and we put all the data, and artificial intelligence is used to help us retrieving the right data that we need. So I'm talking now to all of you that I heard some of the questions how we can use it. Well, I mean, it's not about, it's really having the right objective and to learn how to gather the data. Artificial intelligence is able to do things that no human kind will be able to do, but we need to know very clearly what we're looking for. And that's so it's about asking the right questions to the artificial intelligence. And about prediction, we're working, for example, today, not in 5 years, okay, already today, we have the opportunity, thanks to the use of artificial intelligence, to work on the predictiveness of the tire consumption, for example, by by knowing the amount of kilometers and the type of roads that have been the cars or the vehicles have been doing. We are able already to predict the level of tire consumption with extreme precision, with an error that might be of 1 or 2 millimeters maximum. This implies, the possibility of working on big fleets, and we're talking about thousands of vehicles, with predictiveness that only 5 years ago was absolutely unimaginable. So I think really it's about having a clear vision of what we need or what we need to find, and the instruments are there. There are a lot of people working on it, and I do agree that in 5 years from today, it will be as much as doing a ticket on an Excel file.
Great. Thanks, Mark. You're really an example. I mean, you start giving us examples on what AI in daily life of people living in mobility and working in mobility ecosystems, let's say, do like. I would like to come back, so we do the round backwards to Amit, to ask you something. I mean, you mentioned data, and I like very much because it gives more closer to me that I almost don't know what artificial intelligence is. That is parallel with Excel. So one day I will be able to do the same things as I do. The question,
even today, you can do
the question. I take your invitation on looking for 6 hours course.
I have also introduced this course.
Yeah, no, my question is like, we know as researchers how important are the data. So what kind of data, what are the characteristics of the data we need to find, to input in order to, let's say, drag the most out of this process you were describing?
Yeah, thank you so much for this question. Actually, the complexity of AI in the organization starts exactly from here. So not from the algorithm or the method. However, finding the reliable and pre-processing of data is actually the start of the project. I mean, that's it. Maybe right now, as you mentioned, many organizations or people don't know about these packages, these libraries, these, for example, Python in this case, or TensorFlow, this method. But the main job starts from the preparation of data. Before this case, I would like to comment about the last point that also my colleague said about it is scary about this kind of. Yes, of course, this kind of the progress in AI is very scary, but it doesn't mean that it's bad. Because at the end, I'm a kind of a person, I said that AI is a tool. It's not a kind of the individual entity from human. It's tool. The question is that who uses this tool. So, for example, a good example is the publishing machine. For example, in the Renaissance time, and the Gutenberg, for example, invented that, and then some intellectual people at that said, no, writing with hand is more spiritual in comparison of the generating of the books by machine. Yeah, it doesn't have the spirit of the writing. But hey, if just imagine that Gutenberg did not make this big job, and then we didn't have this kind of the Renaissance and this kind of the revolution in idea, and many things happen. So AI is like that. So we should use it, we should adopt that for our purpose, and then we said that no, it's not a good thing, we should not depend on the technology. Don't worry, dictators, they use it. Yeah? And then these people will eat you in the future because they have a bigger tool. So now it's a time that we use this tool as well. Now, come back to your question, data. When we are talking about the socio-economic system, so for example, prediction of business or customer, so we have the nature of data, for example, is coming from question, or is coming at the demographic data. So for this kind of the data that we can use from our customers platform, we can use surveys or this kind of we use, as I said, that simple or middle machine learning class, because although the data are complex and it's not easy, but the sample size, we are talking about the 10,000. Even, for example, we are talking about the millions, yeah? So in this class of the data, we use, as I said, that the simple to the middle classic machine learning. So, and then if the data you are talking about the image processing, just one image is 1 million pixels, for example. So, and then imagine that you have a camera and you input, for example, millions of data just in, for example, 5 minutes, or for example, in a very short time. In this case, this method that we use for the socioeconomic problem is not usable. So we use deep learning as a, for example, neural network. So what's the deep learning? It means that we have a different algorithm and many algorithms like our neurons, and then by this algorithm we process data. So at the end, the type of the data, so as I said that if we want to analyze the market or if we want to solve the, for example, autonomous vehicle and technical question, we have these two different categories. About the preparation of data, so each of these methods has an instruction. So for example, if you want to use, for example, convolutional neural network as an image detection, for example, it said that we should not have a missing data. Or for example, the data should be between the range of -1 to 1. Or the data should be normalized, or blah, blah. So we have 5 or 10 requirements. These 1 to 10 requirements, this instruction you have to implement on your data, and then you can use this method. So the experience and your competency is exactly in this frame. How you can prepare your data, as I explained. I finished this case about the type of data. My personal project that right now also I work with TU Berlin and also other cases is how we can use AI to predict for example, the acceptance of new technology or the behavior of using of these technologies. So in this case, by very simple data from the survey, this very classical data, for example, with the 30 question, but with a sample size of 400 or 500 people, we try to find as a kind of the sentiment analysis, how the feeling, attitude, and perception of people for one topic. And this is actually, I use it, and I also publish a paper in this case. And also again, another point that I remember, the natural language processing is also about using data from tweeters or the big data from text. Also, again, we have a good instructions that, for example, also tweeters as a X, for example, they said that, do you want to use my data, for example, about autonomous vehicle? How people think about autonomous vehicle? Don't worry, first give me $120, and then when you give this $120, you have access to the data for 1 month with the topic of autonomous vehicle, and you can download whole of the tweets and the idea of the people for 1 month around the world. So it's a kind of, for example, we did that before. So it's a kind of, for example, maybe 50,000 tweets in English. For example, you can download that. But this is a timer. Then you have a 50,000 sentences. Then we have the sentiment analysis algorithm, implement that. And then we said that, for example, in this month, 65 people or 70% of people, they have very bad feeling about autonomous vehicle by this word and by this argument, for example. So analyze 50,000 sentences by this case that you can. So just I try to explain that how the examples of using this method and preparation of data. Sorry for
very useful. No, great, because you give us really a visualization, I think, of how it's going to work and the mechanics behind the process. Joseph, you are using, I mean, you have several projects, and I like a lot your approach, saying, okay, let's focus, guys, on what we need from artificial intelligence. So let's use it, but with caution. It's something we know about, something under development, something expensive. So where do you use it, and where do you think, which are the primary fields in mobility where AI is going to be used in the next years?
Yeah, thank you for your question. No, I mean, elaborating a little bit more on the topic of data, which is absolutely crucial. Right? Let's start by saying that each and every AI algorithm has been developed by a human being, right? Yes. Okay. So human beings make mistakes sometimes, right? As drivers make mistakes, right? So we cannot pretend that any AI algorithm eventually will become wiser than a human being, because in its essence, artificial intelligence comes from human beings. Right? Yes. So, what makes you a good driver, for example? Typically experience, right? You get your driving license, you have some theory, you have some data regarding traffic rules in your lanes, what you're allowed to do, what you're not allowed to do, how to use the gears. At some point, you will be a bit of the gears and will become worse drivers, because we will be relying on driver assistance systems, right? Which make us less attentive to what's happening, because we rely on, I will get an alert at some point if I do some mistake. So this makes us, think of it, this makes us worse drivers in the end. The thing is, what makes you a good driver, for example, using this example, and there are many more examples, is your experience. And experience basically is data, right? That you are gathering as you drive more and more kilometers, and you are able to identify or interpret the complex scenario. One of the most complex scenarios in mobility is driving in a city like Berlin. Lots of older drivers, public transport, pedestrians, children, pets, whatever. I mean, it's bicycles. It's crazy, right? It's crazy. So, what artificial intelligence for this kind of vehicles, I mean, it doesn't have to be necessarily full self-driving vehicles. Right? Every vehicle with ADAS systems on board relies on sensors that kind of mimic the human ability of see and interpret what is happening around the vehicle, right? But again, you need to train these systems with lots of data, because the more data that you inject into these algorithms, the more intelligent and the more accurate the decisions will be, especially when it comes to safety critical maneuvers in traffic and transport, right? So I will give you one KPI that I learned the other day. So there are some papers that estimate that in order for a self-driving vehicle to make statistically relevant decisions on what is happening, and this is also something that I want to elaborate on, because self-driving vehicles make assumptions all the time, make hypotheses. I'm assuming that this is, what I have in front of me, but not necessarily what the statistical assumptions that self-driving vehicle is making all the time coincide with that made by human beings. Because, I mean, human beings are much more intelligent than one might think when it comes to relying complex tasks to code, right? A computer, no? So the data, the KPI that I wanted to give you is there are studies that claim that in order for self-driving vehicles to be statistically strong when they make their predictions, they need to have collected at least 250 million driving miles. Yeah, 250 million miles driven are necessary for these vehicles to be correctly trained. Do you know, aggregating the miles driven so far in Silicon Valley by Waymo and Cruise together, do you know how many miles together they make of self-driving, full self-driving mode of these 250 million? 7 million. So we're far from this, right? So my point is, again, and by the way, local or no-code applications leveraging AI might be extremely efficient and useful for some applications, like the ones I'm going to explain now as an example of something that we are actually using with doing, but for some other more complex applications, you do need to go get your hands dirty with the code. So on the examples. So we are, for example, trying to use computer vision. It's one of the types of artificial intelligence out there to evaluate. This is something that we do with our product called lane control. I can elaborate later if you want. But basically, what we do with this software tool is that we acquire images, so either static images or video footage of cycling infrastructure. So we cycle with our app, running and acquiring images from what the app says, right? on a cycle lane, for example, right? The objective of this technology that we have developed is we want to identify when there are risks regarding the safety of that cycling, whether it's a pothole, whether there are dangerous intersections, whether the cycle lane is not segregated from traffic, thousands of situations where cycling is not safe enough, and we want to identify using computer vision which such problems are, or such risks are as we cycle. Right? Because the way we do it still today is by visually inspecting and applying human intelligence, not artificial intelligence, what we see in those images, right? Whether we see a problem, we code it using a methodology called cycle graph. Basically, it's coding what we see using some standard attributes of what we see. Whether it's a football, whether it's delineations, natural, whether the curvature of the cycle lane is differentiated, this kind of thing, right? You can do a number of things using computer vision, right? So you can determine, for example, how width the cycle lane is using computer vision, right? Or you can detect photos, or you can detect faces of people that you want to blur in order to preserve privacy. Which is something that we do, for example, with standard algorithms that are, mainstream. You are available in the market, you use them, you just plug them, they are trained because they are capable of identifying faces, and they have been trained by whoever that gives this software to whoever wants to use it. By the way, whenever you, for example, are faced with with this CAPTCHA things from Google, prove that you are a human being, right? That you are not a machine. Identifying a bicycle or a bridge or you're training an AI algorithm and you're giving this for free, right? You're training the algorithm because it's thousands, if not millions, of people labeling that image. Here there's a pedestrian crossing. Here there is a bridge. Here, and you're labeling these images and you're giving this information to Google completely for free, in order to make the computer vision algorithms more clever, right? So we do these kind of things, and we realized that neural networks, for example, might be useful to take a number of things. Some of the things completely impossible, or most impossible to detect using artificial intelligence for a use case that, again, I tell you, it's not rocket science. It's looking at how the infrastructure is. So it's not self-driving cars. Simple, right? There's a plot, right? Of course, it's easy to look at. Right? But for some other things, not that easy. Because you use, object detection, semantic segmentation, these kind of techniques, right? But I tell you, from our own experience, you need thousands of correctly labeled images in order to train the algorithm in a way that the algorithm produces something that is better than what currently our consultants are producing whenever we analyze cycle lane. And these are thanks to all the technologies that are used and the claims that are using AI, for example, for inspecting roads. Okay. There are companies out there that use AIs to analyze how safe a road is, including a number of things, including the physical infrastructure, but all aspects such as the digital infrastructure and all stuff. But this is only one example, and this is one more example that I want to reflect on. You were mentioning before that you can segment or identify user behaviors or user patterns and then train your models based on that. I said at the very beginning that we as a company not only we do consultancy, but we do also applied engineering, applied innovation. So I told you about one product called Lane Patrol, and there's another spin-off that we have, a successful one, for DRT, demand responsive pricing. That is a very common technology, like you can find in many countries. In Spain, you might have this technology, and not the same. And this is basically, the ability for a passenger to request a trip on a bus on demand. Instead of fixed routes, you can summon a bus on demand, and there is an intelligent algorithm behind, kind of deciding whether or not that service request can be tendered by deviating a little bit the route of that given bus to pick you up. Right? What happens is that there is friction with pickup locations and pickup times of that particular bus, because that bus is not following always the same route, right? Following routes lead to service requests. If you can train, and we are doing that with AI, typical user behaviors, and then estimate things such as that because there's also accuracy errors in the location of that passenger. And I tell you, the next difference that service request came from one side or the other side of the road or the street when it comes to tackling the vehicle with the passenger. Sometimes it generates a lot of friction to the extent that service request is not met. And this also leads to user acceptance and all that topics that we also mentioned. Right? So using AI is a very promising approach to kind of estimating or anticipating where that particular user request comes from, in which direction. I mean, the direction, of course, we will there before, but the user pattern and training the algorithm with origin destination data and so on can provide, at the end of the day, or that's what we believe, a better satisfaction from the customers, because we eventually will be meeting their needs more accurate while using some sort of AI in the process. So that's only two examples where we are in the real world using AI and kind of problems that we see.
Very, very interesting. And let's fly higher again. I would like to ask you about the relationship, the need for governance in the AI, something you already introduced in the beginning, but I think you might have some, let's say, precise hints. I mean, AI, as you see at commercial or at, let's say, project level, can have some specific applications, but there is more. There is a need for governance of data, of algorithms. What's your view on
First, I like the contributions because it shows that we have two fields of AI. So one is when it comes to consultancy, aggregate new types of data, find out new thinkings, put new elements together, but it remains in the level of consultancy. So no one chases you for having the most reliable results. No one chases you for that ground truth, that the ground truth is correct. Let's move to the organic thing, Homo sapiens. We all know that even by having the best eyes and best ears, there can be a fata morgana. So there is potentially the case that our cognition fails by interpreting correctly what the perception elements, the sensory level tells you. So the reliability of sensors plus cognition is not a given, and it could be that the American way of thinking is statistical questions, but it can also be, and that is a European way of thinking, that it has to be proven by an ISO. The International Standardization Organization 26262 tells you for automotive safety, please demonstrate to me, not as safe as humans, but demonstrate to me safer than humans, that your operation is compliant to my standard. This is one, when looking into the big picture of autonomous driving, we don't want to have a world with a transportation system as safe as humans. We want to have, that's one of the big promises, a transportation system that is safer than humans. And speaking here at the Technical University, today the level is at 10 to the power of -7 operating hours, and we would like to bring our braking momentum control to the 10 to the power of -9. That means 100 times more safer in the as-is situation. This is one of the big elements when looking at European Commission discussions, when looking to the working groups we're having, to bring up the safety level, the safety target for autonomous driving operations to a new level, which is not the case today in cities nor in operations. Let me give you, when you ask the question regarding data, from top level view, let me give you one example. Today, one of our biggest clients is BMW. BMW has a need on their production plant in Ingolfing for one of the vehicles, the BMW 7 series production, to operate from one pole to another one. They just maneuver they want us to maneuver them some parts. This operational design domain is not the same one as driving without an operator downtown New York. It is doable. Today's operational design domains allow for taking off the safety attendant, but it's a 3-shift operation. So operating in 3 shifts, 24 hours, without any standstill, without a human intervention, a running system on a plant, so to speak, and it is now the case with an automotive client. It could be a pharmaceutical client, it could be an airport, and so on. Those that have this high need of performance pressure. Because this is when we want to translate this kind of discussion into business. It is about performance. Business means for autonomous systems be performant and be minimum as performant, we just discussed safety, as manually supported or driven system. Or ideally be even more performant because you have a supervision system that brings you into that performance level or performance category. A 2-minute standstill for us in this operation costs money because they do have thousands of euros standstill on their side if our system fails. So, and now imagine I would come and you are now the client, you are now the employer, I come to you and ask you, hey, I would like to integrate an AI system. What's your reply? The reply is, come on, just prove me that you remain the same safety and that you've got exactly the performance which we detailed in our service level agreement because you promised me a specific service. Shift a child, a human being, a little child. If I would green light whatever my daughter tells me what she sees is correct, I would completely fail because it's simply there's so much imagination in her head and so much fantasy. It's simply not the correct interpretation of the world. I have to bring, that's maybe a question of adulthood, but some people still as 18 are not adults. The ground truth I spoke earlier has to be implemented now into this head of a small child. In our public ground world, this is done by TÜV, this is done by DEKRA, this is done by an approval line. This is not existing. In today's world, and where we want to implement AI, it's simply not existing because this way of approve what I listen and what I see is correctly interpreted is kind of undoable. It's a task that can at the moment only be provided by a statistical measurement or by what I said earlier, the ISO approach. But to bring this into compliance, that what you hear and what you see can be transported correctly into I'm allowed to filter. And that's actually my main message when you asked me that question to the government. He was, when he had the first words, he was doing this whipping with his feet. And you are maybe, when I look in this direction, you are taking off your hand from your mouth. Maybe. She was leaving for the toilet for a second, and I saw it, but my brain told me it's not important for my vitals. I can sit here, it won't let me freeze, that my skin has to be activated to provide me shelter with my hairs. It's nothing that I got any other turbulence in my head. I could filter it out. It was safety non-critical. So I could take out his whipping. I could take, even if Massimo would have something said or whispered in my ear, potentially my brain would have been smart enough, speaking about the 1,500 cubic centimeters brain volume, we are smart enough to activate filtering mechanisms. Some people are not, the autistic people are not for this, for instance, to filter out exactly what I need to be in order to be safe. For instance, walking on an unsafe terrain, walking on an icy surface. If I take the interpretation model of my daughter, I couldn't walk on icy surface. I have to train it on a neurological level. Some people are better, and some will never be able to walk on ice, so to speak. So this training and filtering has to be at a point transported into the performance dreams and wishes from a BMW client, wishing us to bring down their cooling power, because at the end, operating an autonomous system with a lot of sensors, which are all activated in all dimensions, and you may not cut out information, because you have to take everything serious. You have to consider everything as a threat. To give an AI system the allowance to cut out specific elements. For instance, this whipping of the feet, which can happen at BMW side, and our system sees that. But the allowance to say, this is safety uncritical. This is a super big element. Today, no one has ever kind of touched this. This is why you see this discussion, how much energy consumption do you have on board for your autonomous system, and how much cooling power. And then there is a cooling design question for AI systems and so on, because you simply cannot, for today, take out this whipping or this mouse and so on with your hand. You can just take it out, not take it out. But we as humans can take it out, because I know it was not sensible for you. And this sensibility discussion, and in group sensibility discussion, it's not a sociological discussion. It's an approval. Government has to say yes or no by a regulation discussion. This discussion is still out there.
May I have one quick about the last point? I mean, I'm not a fan of AI. I'm an absolute fan of AI or critical. But you know that the new AI, and we are talking about the generative AI, we have different layers. One of them, I can say that the most important layer of the modern AI is feature extraction. So exactly your example said that we have lots of data. And of course, they are talking about the lots of data, means that we have lots of noises or unrelevant data. So I mean that, for example, for CNN as a convolutional neural network, the machine doesn't process all of the data. Because if it processes, it actually we consume lots of resources and also state. In this case, we have a layer of the feature extraction, means that among of these millions of data, which are more important for my decision. So for example, for the face detection, machine learns that, for example, eyes in this area, noise, or for example, this part of that is very important to detect the people. So then by this layer, machine tries for the learning process. So I mean that say that even right now, the deep learning, it works on the, for example, feature extraction, cutting of the data, which is a kind of the noises or extra data, because otherwise machine cannot handle the big process. Yeah. What do you think? That this is, that in my case, I'm pretty sure that we have right now this technology to exclude irrelevant data or noise. I think that you can express it in a very
I mean, I saw a video the other day. You were a bit because I'm telling you, right? So you would agree with me that trees don't move, right? They're planted. It's in cities like this, they're planted, right? I mean, that's what we understand is true, right? What happens when you have a lorry with a gardener carrying a tree, catch tree? on a lorry, right? It's a moving tree, right? It's a tree moving at 50 kilometers per hour. Pretty strange. I tell you, this makes way more cars crazy. There's a video on the internet I can share later of a way more car, taking a tree 50 meters ahead with its radar. The radar tells there is a tree 50 meters ahead. Indeed, there is a tree 50 meters ahead of you. The radar works, right? And then when the car approaches the location of that tree, the tree is not there anymore because it's on a lorry, right? Traveling at 50 meters per hour. When it gets to that particular place, you know what Waymo does? Still, it steers the direction to avoid a tree that is not there anymore. Super silly behavior. Super silly behavior that every single human being, including your daughter, would not do if she was allowed to try it. No? If she was allowed to try it. So, and there are hundreds of those examples where AI still today, even AI developed by the most advanced companies in the market, when it's one of those, which, by the way, are still allowed to operate with full self-driving mode, those were suspended in San Francisco after driving a pedestrian, very bad accident. So they were suspended, and there were other incidents. You might have seen those incidents involving cruise cars, stuck in the middle of the street and creating problems, right? But Waymo are still allowed to operate in San Francisco for self-driving mode, and they are making these seriously mistakes. And there are dozens of examples where the sensor fusion happening and the decision making happening in the brains of self-driving cars makes these stupid mistakes. So this is to say, again, whenever we are thinking of AI, we call it AI, by the way, but it is, we call it like this, it's software taking decisions, right? We could agree that more simple, less buzzword-like definition of AI is a software that takes decisions as a human being would take them, right? Okay, this has been around for many years. The thing is that we now call it AI because it's trendy and because it's not. But coming back to one of the topics that I think is important, if we apply AI some use case, it's because we ideally see the value in doing so. Again, this might sound like too obvious, but if there's no other value, if there's no business case, if there's no, why the hell should we be doing that? And I question, that's a question that I want, I share with the audience, whether, for example, robo taxis are such a beautiful idea. Do you think it's a beautiful idea to use a robo taxi? I don't think so. You know why? Because robo taxis generate a lot of user aversion. The people who paint these vehicles whenever they are deployed in San Francisco as well, social movements that hate this kind of technology because they think that they might cut their jobs as taxi drivers. In my city, yesterday, there was a huge demonstration, huge one, very aggressive one, of taxi drivers against TNCs, against the Ubers and Uber. Human-driven Ubers. Think of self-driving Ubers. They would kill them. They would kill them.
I was understood that artificial intelligence is not perfect in all the aspects, and there is also an aspect of discrimination of the artificial intelligence. I read recently that probably there was a robot taxi which was not recognizing the dark skin faces or makes mistakes because it assumes that there is the average customer is a white male. And we also have an example. If you ask, for example, ChatGPT, what a 40 years old woman makes in the afternoon, then the ChatGPT will say yes, she's comes from work, she makes her chores, her household, and takes care of her kids. And if we say that, ask the same question, what does a 40-year-old man afterward does, then they will say they do their hobbies, they do their meetings, they do their family time. It's not called chores or childcare, but family time, of course. It's a quality time there. And so that's why we should really be careful what we do, because this is, of course, unacceptable. And if someone has dark skin or is a woman, I'm sorry, why should I be discriminated just because I don't respond to algorithms which were done by obviously white old men? I'm sorry.
This is the ethics sphere of the discussion that we're having today. We had the technological matureness discussion, we had a sort of legal framework, compliance, etc. This is the ethics level of whether or not using AI or how we train AI on which principles, on which assumptions, on which prejudices, and these kind of things, right? It is one other sphere of discussion that is very complex but very necessary, right? Particularly when it comes to generative AI. And you were saying that in 5 years, AI is going to become mainstream. Yeah, I say that it is today. Yes, who in the room is not using ChatGPT? Yes, this kind of tools. Everybody.
Can I just, before we go to Marco again, what you are pointing out is that this new technology can replicate social ranking. And there was also a few years ago, autonomous vehicles could not detect dark people, dark-skinned people. And I can go on, like the latest is this new artificial intelligence tool where we have this very effusive and flirting lady replying to you, which is horrendous. I cannot say different because it's not used to make change, but is used to replicate what we have today. So there is this ethical issue. But as you say, the ethical issues enter into the frame because if we don't address these, then we have a certain technological rejection. And then all this discussion is going somewhere else because the correctly so, the rejection of new tools. And this is something we shouldn't underestimate because any moment the first day we started, we said, perfect place to have digitalization is a logistics center because there are no humans. Oh my God, that's perfect. There is no problem there. The moment you put humans, we have feelings and we have emotion and we want to do something in our life. And therefore, we need to address the humans in the room. And this is when we should also look at acceptance. And in any of your project developing, this is absolutely crucial. Your biggest headache will not be the technological one. It's maybe finding the right person working for Siemens Mobility and looking for the cost of the data and looking for making the stakeholders accepting, which is your vision. I stop here, then we can let Marco and then we can
check. Sorry, Marco, we heard from you so long ago, but I have another question also for you. I mean, you will present the practical users of AI, and you told us it's not in 5 years, we are already using it, and it does this and this. Like, what's your view on the future? How do you think you are going to use it? How do you think it's going to affect the evolution of your business?
Okay, thank you all. Actually, I would like to take some of the things that have been said that are absolutely interesting for me, and it's one of my major points when I have this kind of meetings, which is I heard about image gathering, behavior, and road safety. Just to summarize a little bit. And I would like to try a small experiment, digital experiment. So let me try to, instead of speaking, showing you some images and videos, and then to comment them. I'll try to share my screen. Let's see. This was not absolutely prepared, so let's see if it works. Okay. Do you see my screen now?
Almost. Yeah, yes, now we do.
Okay. So there are three sets of images. I'll try, let's see if it works. Also this one, the video. Okay, you are seeing the video movie now.
Yeah.
Great. You see two videos basically, one front facing and one facing inside the vehicle. And again, for the second one, then we will comment them. Just try to take a look at what's happening outside and inside the camera and see the different behaviors. So since we talked about behaviors again, and look, the third one is quite interesting because it happens at night. So you see what is the driver doing. So I'll just stop sharing and stop sharing. Okay. So this is what's happening. This is the power of AI now. These videos are grabbed from a dash cam, a video camera with artificial intelligence inside. So the importance of this video is that we don't grab all the video, we don't record all the time. The camera starts recording only when it tracks weird behaviors. And weird behaviors for us is distraction, smoking, or tiredness, so closed eyes. And see here, it all comes together, what we've been talking up to now. We don't need to gather the information set into the artificial intelligence, and the camera is able to track our behavior, but not in a, here I hear a lot of privacy issues, which I understand very well, and I'm aware, and we are aware of this privacy issue. But imagine the value of this, because you saw that the drivers changed their behaviors, and you know why? Because the camera actually has a sound, and it's actually the camera is telling the driver, stop doing what you're doing because it's dangerous. You saw the first driver was driving into a small country village, looking at this mobile phone. This is one of the most dangerous things we can do in a car. And actually, this is one of the cases where today artificial intelligence is already changing in a positive manner our behavior in a moving vehicle. So I think this is with a few images, I think this sums up what we can do today. Imagine what we can do in 5 years from today with these simple instruments. They're really easy to install, easy to use, and there is an immediate positive reaction from the driver, because it's not, the value of this is that it's not someone else telling them, so it's not his boss or his manager saying you're not a good driver, but it's a machine with a tool that is rationalizing all the behavior, and it's actually saying, well, actually, I understand that I was putting myself and other people in danger very, very clearly. So I hope this helps to put into reality what we've been talking up to now.
I'm doing the bad call because we have a little bit of time, then we have to go for lunch. I would like also to maybe just a very short, because you are using, I think, quite a lot in recharging electric vehicles. You would like to have your predictive analysis and data. So if you can have a very short input about how much in real life real people are using that from whatever you can share with us, of course, it would be nice, and then we can go back to the panel and also getting more questions and keeping discussing for that.
Yeah, I mean, the real life that I'm aware of for charging and applying these kind of data happens behind the charging station, because what is really interesting for many of these so-called CPOs, the charge point operators, is to understand when their next customer will come, when they have to order the industry, will their plants be cool enough, will it be pre-configured, and in order, of course, you can try to blindly forecast using just the data you have, but the best thing is always when the car says, I'm coming, when there is a booking. So you open the model, you go out from this very subjective single data point that is sort of a very simplified copy of the world, and you enhance the model, and you make it a multidimensional model, no longer just the charging station view, but also the moving asset view. And this is really my question to you. Every extraction of data from the outside world basically creates a copy, a simplified copy of the world. How many copies do we need before we can speak of a digital twin? And how many digital twins do we need before we can really speak of a digital representation that contains enough causal effects to actually explain and causally anticipate behavior instead of just guessing statistically?
To me, explaining may not be the end, because that was what I said earlier, what I liked in Marco's presentation. It is about liability. And at the end, what I said earlier, when we are on private ground, I just take responsibility for myself. Then it's on me, liability question. What said, we have to clarify first if we speak about a level 5 system or level 4 system. And this is an elementary decision to be taken, because otherwise we have a liability crash in the discussion. What you said is a tree, this moving tree, is a fatal topic because it can create fatalities. So someone has to take liability for the fatalities coming out of that, the misinterpretation. So this is why in Europe we do not accept why Waymo is not operating, because basically the understanding of a system like a robotaxi doing a job by taking decisions, but we do that physically, not just in my longitudinal way, but also laterally to clear in both dimensions every time instance to clear decision-wise what has to be taken as next step. And yes, oh, there is a tree, oh, it's moving, why is it moving? This is a way we say we restrict in Europe, we do not want to have classes. What we do instead is to consider the world as a static framework, and we put trajectories into it. This is a level 4 approach. And we say, you have to take care when you are on your pre-programmed trajectory that nothing that is left and right or above you is of danger in terms of liability. That means you can put the system, the AD system, it's not the same AD system from Waymo, it's a level 4 trajectorial-based AD system. You can put that into liability. We are put, taking again the BMW case, into liability. Or for you, you have your charge point topic. It's at the end a profitability or convenience factor. It's a consultancy service to get better data, to get better knowledge and so on. But it will never affect your liability. Whereas when it comes to fatality discussions, personal damage, injuries, or injuries and damages of common goods or infrastructure, there has to be an insurance company that takes the insurance power and says, yes, I do that. And this discussion, I mean, that's a good combination actually for my closing statement, so to speak. As long as we haven't given AI a specific role when it comes to liability, or we give a specific power of liability to AI, to me, it must remain in a position of a consultant service, like in your case, and we have many others on public services for cities and so on, where you can profit from AI on a consultancy basis. But when you cross the border into the liability world, where an AI system has decisional power, where it gets into the danger of goods and life, it has to be treated differently.
Two things. On the system level thinking approach, that is crucial. That's absolutely crucial. So the more information you have on your environment, the more trees you understand what is happening, what is critical, what is important, what is not important, the better, the more safe that particular mobility service in the case of self-driving vehicles will be, right? So there has been research and some task force a few years ago, in fact, where there was a proposal, I believe it's still on the table, that whenever full self-driving vehicles or highly automated vehicles are involved, and the traffic management center managing traffic in that given area, city, whatever, would also be a participant in the orchestration of mobility. In other words, so it will not only be the car through its sensors and its perception of the environment, the one that will be taking decisions as we human beings do, but there will also be another participant, the traffic manager, sending instructions to that vehicle either through the internet. That's another, connectivity aspect that we haven't discussed yet, right? You know that there's not always enough connectivity, or there's not always the right latency, where maybe connectivity is concerned. Some things come into play. But in summary, so you were asking a question that I believe has no answer yet. At least I don't have the answer. If I have the answer, it would be some, I don't know. Anyways, so training a digital twin with enough data is something that is absolutely needed, otherwise the digital twin might render useless or not that interesting. We're far from here, and the system level thinking is very important. So all participants in the orchestration of mobility in a given area need to participate, particularly where algorithms are in charge. And the second thing that I wanted to say, which I believe is quite relevant news that happened a few days ago, the UK has passed a law by which, since a few days ago, that there's a law in the UK that states that whenever a self-driving vehicle is involved in an accident, the OEM is liable.
Who is liable?
Sorry?
Who is liable?
The OEM, the manufacturer of the car. And I mean, this might sound like obvious, but I mean, if you think of it, it's not that obvious. I mean, it might be, but it might not be. I mean, if it was that obvious, it would be in every Western world country where these kinds of vehicles are intended to be deployed, that the laws are already passed, right? Similar laws. It's not the case yet. So the UK is kind of pioneering and paving the way for the critical question who is liable in the case of fatal things happen.
Yeah. Just to complement that on European end, and Brexit, it's the opposite. So when the British people decided to put the OEM into place, on European level, the AD providers put the charge. That means for all the approvals, the AD provider has to make sure I prove my safety and how the mechatronic system looks like. That's not a question, but I bring into traffic this specific thing, moving and so on, so it's a liability to us. So that's a very interesting thing that the British government has decided to take the OEM instead of the AD provider into liability.
Yeah, I think that you explained completely. And also just, I think that all these examples is that you have one charging point, and then you have a different request on this case, yeah? So just my question, how is this system can be complex? I mean that you have the two options. There is occupied or there is not occupied. I mean that yes or no. Or the numbers of the requests are the no question, I mean that you have in this case. So I mean it depends on the complexity of your question. I mean that in your question, my understanding is not too complex. I mean that you have a 2 or 3 or 4 scenarios based on the number of the requests. Now, the question you ask how many abstract board or how many, as a copy of the board you need to have a one reliable charging point, yeah? in this, about this charging point, I think that we don't need many. I mean, that it's not the kind of issue here. I mean, that it's very practical. How many data you need? I think that is the next question. So, of course, I really like your example about the one year that, or the kid that this year or this kid sees something as an imaginary and then also see some fact and how we can distinguish between them. So this is a kind of the learning process. It's a kind of the transition path. Right? You should not be in the beginning, it's a very perfectionist that right now it will give me the perfect answer without any mistakes. Even about the driving is a very unconscious skill. I mean, if your wife, or my wife, I mean, said that, oh, honey, there is a one thing. After that, I'm really overcautious for driving because always I think that maybe I see something, I didn't consider something in my driving. So again, come back to the learning process. It's a transition time. I think that it depends on that, but in case of the gear, this analogy or this example, I believe that AI has this time very faster because people save their, I mean, as your example, share their data, the processor getting better and better, and some of the questions such as the charging process is not very complex question. I mean that right now, even again, come back to my case, Excel form, you can right now improve, I mean that they give the data 1 month, and then you can see the patterns of the request. So what do you need? I mean, okay, so maybe about 60 or 90% is enough. You don't want to be a god to say that, okay, 100% I need the reliability for charging point. No, you need 80%, yeah? But also you can do. About the autonomous vehicle, yeah, this is a very case, you agree, I mean, that this is about the safety. Hey, look at the Berlin. I, as a professor, I mean, as a lecturer of sustainability, always encourage people to use bicycle. And I know that every year, 60 people were killed by bicycle in Berlin. Well, accident, a car accident. If you, I mean, if you see this, I mean, the cross, you see that, for example, white bicycle beside of the line, and then I ask myself, like, hey, I always encourage people to use bicycles, and every year 60 people will kill only in Berlin. Should I do that? I don't care about the sustainability, but 60 lives are here. Now, this is a moral question, an ethical question. I'll come back about the AI. So we have to agree or accept some transition time, okay? But of course, this is a learning method and it improves and improves and improves every second. So then you can get the maximum level. But if you stop right now, always put many regulations against the AI, and I mean, so there is no opportunity to improve itself, yeah? About the Tesla, I remember one of my friends wanted to buy a Tesla, but there is a very good offer from Tesla in 2022. I mean, at the 30% discount. Then this person called Tesla and said that because of 30% discount, do you reduce the number of cameras or some of these smart things in this bit? The answer of the developer or seller is super interesting. He said, 100% sure, if the prices decreases, but never ever Tesla decrease the number of cameras and recording and smart tools, because this is the main business of the Tesla, gathering the data from the system and improve itself. This discount is coming from the other cases, but not because of reducing this. So now, right now, Tesla almost just for 3 years in Berlin, gathering the data of our streets, improve of that, and improve their models. I mean that, of course, as you said, that we do. And about the case of Los Angeles right now, we have a taxi robot, in this case, much, I mean that they give it a little bit freedom to do it, and then they get the result. Yeah, they accept that somehow. But anyway, I said that you have to sometimes accept the risk or the failure. But at the end, after the transition time, we have better result. Yeah,
there's something that I want to tell you because I drive a Tesla.
Yeah,
right. I'm into this business. I know a thing or two about AI, mobility, self-driving, etc. Not much, but a thing or two I know, right? I tell you something. Teslas do not use LiDAR sensors, unlike all the brands that they do use LiDAR sensors as part of their stack of sensors, sensing, like the reason being that this is one of the most expensive sensors that can be used in these distant vehicles. They will not tell you that they're not using the sensors, that people do not know, and people like me. I'm a bit biased because when I'm in a Tesla, I'm second-hand, I'm in this business, and I know what this technology is able to do and what it's not able to do, so I'm a bit technological skeptical in some cases. So, for example, the full so-called full self-driving mode, so the so-called autopilot, right, in Teslas, is something to impress your mother-in-law. Full stop. It's something to impress your mother-in-law, your friends, or my kids. So my kids, not right now, but at the very beginning, they say, "Oh, put on the autopilot, no hands." No, but this is only for impressing friends. In practical terms, completely useless because the system is engaged for 10 seconds because it does not interpret what's around in a decent way, so, which makes it a very dangerous system, right? So my point here is when technology like this becomes mainstream, because AI is going to become mainstream in 5 years.
I said that right now is amazing, but I said that these people can use AI for your own day. I understand it as an Excel. I didn't say that. Okay, right now we are in a mainstream. AI is better. There is a once. There is a once.
But my point is, there is AI in the market that is cheap enough for people to afford the Tesla, 30% discount, which is dangerous if you're not aware. Why? Because it doesn't detect obvious things. I tell you, the autopilot feature in Tesla, like my Tesla, is completely useless. It's only for
discussion about Tesla for lunch.
Because I have it, and I don't have any problem for the party.
The most thing we
Yes, Marco, if you want to say a last word, unfortunately you cannot be with us for lunch. Next time, next edition for sure.
Yes.
No, thank you very much. No, it was very much interesting, and I think thank you for the invitation. And next time I'll make sure to be present there on stage.
Splendid.
Thank you very much.
Thank you. Thanks a lot, Marco.
They take advantage of the question because the question is not when the station is full or empty. This question is how long the people stay at the charging station. How much rains impact the use of my charging station? How much the football match impact how many women and how many men are using the station? Should I put more lights because it's not a safe one? So the question is again and more than anthropological research, if I can push it with the agenda, and we know that the user experience is at the end of the day anthropological, and is getting also very more complex. So I think that we know that there is no answer for your question as much. I think it's very close to your case. How long the people are parking in downtown, and how many of these are working in the shop and keep the parking lot busy all day? How much are locals? Are their clients? Are just and then you can replicate for any of your cases, logistic is very close to that case. So you have these people. At the end of the day, I like the idea of becoming Excel. I already have a problem with Excel. I don't So I'm very curious to see what's happening. And at this point, I'm very sorry there is no time for more questions, but you should explore the speakers and our special guest also during lunch. Now we have to go. Sorry for that. Thanks.